Hello, everyone. Welcome to Scientific Reasoning Module 3. This module will focus on reasoning process. Particularly, we will focus on inductive, deductive, and adductive reasoning. My name is Huihui Wang. I'm an associate professor at Agricultural Science Education and Communication, Purdue University. This professional development is part of industry-driven integrated STEM and system approach to innovate incubation project. The project is funded by USDA and NIFA. There are 5 modules in this theory. The module uses the roadmap to guide your learning experience. The third module focuses on the type of reasoning process, which is an important component of scientific reasoning. Scientific investigation involves process of inquiry, experimentation, evidence evaluation, inference, and interpreting results that support or refute the hypothesis. In this module, we will focus on inductive, deductive, and adductive reasoning. Let's review what you have learned before. In the module 1, 2.1, and 2.2, at the beginning of each module, we have introduced you some content knowledge, such as what is data, evidence, what is full fraud. There are different types of observations, and so on. These are contents or prior knowledge that you will use to conduct scientific reasoning. These contents and/or prior knowledge are domain-specific, which could only apply to certain contexts. In the module 2.1 and 2.2 that we have discussed the hypothesis, observations, and experiment design. This knowledge are considered as a domain general knowledge, which they could be applied to different contexts. For example, if you know how to generate a good hypothesis, it will not matter if you are trying to figure out why your neck feels sore today or why your water tastes badly after raining date. To know how to ask good questions, generate testable hypotheses, and design experiments to answer the questions are also important skills that a person needs to conduct scientific reasoning. Finally, in this module, we will focus on some reasoning process. Reasoning is a process that a person tries to figure out questions or to solve problems. Reasoning also is an important part of a scientific reasoning. So, what is reasoning? Reasoning comes in diverse forms, such as everyday decision making, for example, paying with a card or cash, or making a decision that impacts society. For example, Center for Disease Control and Prevention has expanded recommendation for COVID-19 booster shot to all adults age 18 years old. Reasoning is the ability to assess things rationally and logically, based on new or existing information when individuals make decisions or to try to solve a problem. For example, and then also, STEM literate citizens should conduct logic reasoning to make a scientific sound decision. What does that look like? For example, do I buy organic egg or not? The prices is like a $3 differences between organic egg and non-organic egg in a dozen. Now, I'm thinking, do I have a good reason that I should buy organic egg versus vice versa? If I choose to buy organic egg, are those eggs really come from organic farming process? Do I want to pay $3 more for organic egg? To make those decisions, I might think about nutrient value, animal welfare, food fraud that we just learned. How much do I want to pay per eggs, and so on. It might look really simple when I choose the egg that I want, but in fact, there are many information involved the process how I choose eggs. Those informations are based on my prior knowledge, my need, my belief, and things that I have learned. Therefore, a simple act, like I'm trying to solve a problem or just to decide which egg that I want to buy, involve data, information, or evidence. The data, information, or evidence from your experience and prior knowledge, or things that you learn from other people's books or internet. The information that you use to solve problems does not really need to involve experimental design. Just think about this. In your daily life, how many decisions that you have made unconsciously undergo the reasoning process without experimental design? Probably most of them. In addition, as we have mentioned earlier, your value and belief could also have impact on how you make your scientific sound decisions. For example, do you believe organic food? If you do, then buying organic food will have more weight in your reasoning and decision-making process. As for motivation, for example, if I don't care what type of eggs that I ate, and I don't care about the price, I probably just grab any eggs that close to me when I shop in a grocery store and go. I don't want to engage any reasoning process to decide what type of eggs that I need to buy. In other words, buying organic eggs or not do not worth my time to think about it. So in this module, we particularly will talk about 3 types of reasoning: inductive, deductive, and adductive reasoning. Please note that there are other reasoning, such as probability reasoning, correlation reasoning, hypothetical deductive reasoning, causal reasoning, other than inductive, deductive, and adductive reasoning. All those reasoning processes could help a person make a decision when he or she trying to answer an inquiry or solving a problem. Let's use Module 2, What Do I Test? The adulterated honey as an example to explain inductive reasoning. In the Module 2.1, remember, I asked you to guess what was I test in the video. Whether you have the right answer or wrong answer by then, when I asked you to do this activity in the Module 2.1, you had engaged in some reasoning process by then. In the deductive reasoning, which also is called evidence-based reasoning, you have some information to help you answer the question or solve the problem. In my case, I know something was added into the honey, but what? I know from my science class, which I took a long time ago, that if liquids have similar chemical property, they will mix, such as vinegar and water. But those does not have a similar property will not mix, which is like oil and water. So I assume when I observe the 2 different samples that whatever added into the honey has a similar chemical property because I don't see anything's not mixed. Then in the video, I saw sample A stay put on a paper towel, but sample B dropped to the side quickly and it left watermarks on the paper towel. These were my evidence from my observation. So I hypothesized that water might be act into honey. The two important aspects about the inductive reasonings are individual has a prior knowledge or a theory that is used to accept the evidence present to generate a pattern or find a hypothesis. Mostly, we ask, what is the likelihood of the hypothesis based on the available evidence? In the module 2.2, we ask if overfeed bees with sugars will change the biochemical property of honey. We know that honey is a complex mix of many substances. So we assume that some substance will change if we overfeed bee with sugars. Then we compare two sets of data that generated by scientists. After the data, we learned that in terms of purulence, in both experiments, adulterated honey has a lower amount than natural honeys. For the moist, in experiment 1, natural honeys are higher than adulterated honey. However, in the experiment 2, the result was reversed. As for ash, in both experiments, adulterated honey have lower amounts than natural honeys. At the end, we can make a conclusion that yes, overfeed bee with sugar can cause change of biochemical property of honey. So the two important aspects about the deductive reasonings are individual searching for patterns or instance of evidence present to test a hypothesis. Mostly, we ask, assuming that the hypothesis is true, what things should be observed? Now, as for adaptive reasoning, it is also called exploratory or trial and error reasoning. In the module 2.2, when we compare the actual data from the two research, we found that in the experimental 1, natural honey have higher moist than adulterated honey. However, in the experiment 2, the result is reversed. Now, I'm thinking, why the result is different? Could it be the scientists conduct the experiment in the two different regions? Could it be how many sugars or different brands of sugars that scientists use to feed the bee? Could it be experimental error? Then I'm thinking, maybe it is because one of the experiments was conducted in a cooler area. So, at the time when the scientists conduct experiments, no abundant flowers ready for bees. So bee eats more sugar. So the moist result is different. When I made those inference, do I base on scientific evidence? Well, you can argue yes or no. I definitely base on my prior knowledge to make that inference. My prior knowledge about blooming times in a cooler area is later than warmer area. That is based on scientific evidence. Think about the cherry blossoms in the United States. However, I have never visited the two areas where the scientists collected their data. So maybe the vegetation looks very different from the two areas. So even in a cooler weather, bee might still have the same amount of food in the experimental 1 and experiment 2. So I'm still guessing my answer, right? In our daily life, when we solve problems, we use a lot of deductive reasoning. We try things until it works. But when we try things, we always have a reasons about the things that we wanted to try. It really comes from pure guessing. So, an important aspect of adaptive reasoning is when we're looking at evidence. An individual has a very little or no existing knowledge and want to make a best guess to the simplest answer. It's very similar to inductive reasoning, but adaptive reasoning could be very creative and intuitive. And again, it's very most likely used to generate a hypothesis. Okay, let's put all the reasoning together. As you can see, this complicated reasoning map. I have learned something from using deductive reasoning. I also have learned something from using inductive reasoning. Then I use adductive reasoning to generate some wild hypotheses. Sometimes the reasoning process overlapped to help me make a conclusions. Then after all those reasoning, I have another inquiry now, which is will eating adulterated honey has impacts on my health? Now you see, reasoning is complicated, but we often do not realize how complicated the process is. As you see my reasoning map, I use a lot of adductive reasoning, which pretty much equal to inductive reasoning. In other words, I was guessing a lot to find out the answer. Yet, in the end, I could still say that my conclusion is based on scientific evidence. Is that really a true statement? To be precise, my conclusion is based on some scientific evidence, but it also involves personal experience and wild guess. So now, next time, when someone telling you that my conclusion is based on scientific evidence, think twice about that statement. When we try to solve problems, it always involves prior knowledge, scientific investigation, or trial and error, and thinking process. Therefore, problem solving and scientific reasoning is like water and fish. They cannot live without another. When we try to help our students practice their problem solving skills, we also should help them practice scientific reasoning and help them conduct scientific reasoning. Every decision that we make to solve problems should base on something. But it is hard to observe, inside people's mind. Often, we do not even pay attention to the process of how we conduct scientific reasoning. Therefore, scientific reasoning is difficult to teach and practices. A virtual role-playing games is a good tool to help your students practice scientific reasoning by solving problems. The Climate Trail, Surviving the Climate Apocalypse Games, is a free resource that you can use in your classrooms. While your students play in the games, you could ask your students to document how they made their decision based on what when they solved the problem. For example, how much money they spent on food, why, how many days they have survived, why they failed, why they succeed. Do they want to pay more for food or less? Why? Those are good questions can help your students to think about their scientific reasoning process. Let's reflect on what you have learned. Please fill out the reflection questions in the Google Classroom. Tell us what you have learned from this module. What are the different types of reasoning that we discussed in this module? How does the reasoning play a role in inquiry and scientific investigation? How prior or content knowledge and personal experience play a role in reasoning when solve problems? So far, we have discussed all the components that relate to scientific reasoning. In the next module, we will focus on how we apply scientific reasoning in your classroom. Thank you for watching. If you like this module, we also have another module that focuses on integrated STEM through agricultural food natural resources. Check out the module and website by clicking the link in this slide. If you have questions, feel free to contact me. Thanks USDA NIFA for supporting the project. Thanks for the project co-director Dr. Neil Nabla and the graduate students Brianna Nielsen working with me and give me feedbacks to the module. Thanks for Dr. Crystal Hans serving as a content expert for the module. I will see you next time.